This is talking about the soil capacity. I told you that if we increase the load more than the ultimate capacity of the soil, we'll face some failure surface like this. And these failures lead to, for example, uneven settlement or collapse or many undesirable uh, results. Depends on the soil type. We have different shapes for this failure surface. Okay. Um, One of the common theories in foundation engineering is theosophic bearing capacity. Uh, we have different capacities. One of them is bearing capacity. For example, we have frictional capacity, and but in foundation we mainly work with bearing capacity. Okay, you had bearing uh, capacity, for example, in strength of material, and two element have direct contact like this, the bottom of the foundation and the soil. And here, in this part, we have uh, bearing. If you look at here, you can see that we can define this failure surface that I mentioned with some parameters. And if we know these parameters, we can find the final capacity. What are these parameters? One of them is unit weight of the soil, gamma. The other one is cohesion, C prime, and friction angle, phi. Okay. Do you know how to find these parameters? Cohesion and uh, friction angle. You know what are they from soil engineering? If uh, we we have a couple of tests. One of them is unidirectional test. Okay, unidirectional test. In this test, we have a cylinder of soil. We have a cylinder of soil, and we apply unidirection pressure. Okay, depends on its behavior. We have, for example, something like this. Okay, this is more circle, and this circle, if you find this circle, you can have these parameters. When you, as I said, when you apply the force, you can get this behavior. One of them is tau, shear stress. The other one is sigma, or normal stress. Okay, and then from here to here, if you draw a line like this line, if you, I don't know if you remember it from mathematics, this line has equation like this, ax plus b. And by finding the equation of this line, we can find a and b, and one of them is c, one of them is phi. So Anyway, if you want to get these parameters, you have to perform experimental tests on samples of the soil. In many cases, we have these parameters. If you remember, I told you about three terms. If you remember, I told you about the three main terms that these terms form the main capacity of the soil. One of them was cohesion, the other one was uh,
Load,
what?
load above and soil below. Yeah.
Yes. Uh, from this equation, rho is equal to m over v. If you want to find the weight, what is weight here is rho dot v. Yes, m is volume dot density. Okay, this is mass. And if you want to find the weight or the force, you have to use gamma is equal to weight divided by volume. So the weight is gamma dot v. If you remember, I told you that one of the terms is the weight above the foundation. Look at here, this part. You can see it here. This part is the weight above the bottom line. Here you can see this is the bottom line of the foundation. Okay, this is the bottom line of the foundation. And one of the terms or one of the parameters that forms the capacity of this foundation is the soil here. So how can we find this the amount of this soil? By following this equation. The weight is equal to V or volume dot gamma. Here you can see that uh, Q or do you remember when we talked about uniform load in engineering mechanics? If you remember, for example, if we have a beam, it's low. If you remember, we had Q, okay, and what was the unit of the Q? For example, kilonewton per meter, okay. So in here we have such thing Q. What is Q? For example, you have this foundation, and this is the bottom line. This is the column, and here you can see the soil, this soil, about the bottom line. If you want to find this, the force here or the weight, uh, you have to assume two things. One of them is that you design or you find the capacity for unit weights. What does it mean? That means when you want to calculate this volume, what is volume? For example, the volume here is d length and the thickness w. Or let me write it. I don't know m. Okay, d dot l dot m gives volume. As I said, you have to assume first m as 1 because we are working with unit length, unit widths of the foundation, unit. And when you want to find the capacity, final capacity, you say that this foundation, for example, the Q is, for example, For example, I don't know, for example, 10 tons per meter. Okay, so L is, you're not considering L, or you can also assume it as unit or one. All I want to say is that when you want to find Q, you just need to you just need to consider D, or in foundation we say DF. So the first parameter that you should know in your calculation is this parameter DF. Okay, so DF is the distance from the bottom line to the surface of the ground. In some cases, you may have, for example, uh, like this. Your foundation is like this. As I said, you need to excavate, and this is your foundation. This is your column, whatever. So, what is D here? This is D, not this. Do not make mistake. This is not D. This is DF. The distance from bottom line to the ground surface. To find what, or to consider what? The weight above the foundation. So one of the terms that you have to consider is this one. The other one is cohesion, and the other one that, as I said, is the soil here, the condition of the soil here. As I said, sometimes you have water near the bottom of the foundation. Sometimes you don't have any water here, and you have to consider the effect of this soil below this foundation. So the first one that suggested a formulation for finding the capacity of the soil was Terzavi. Uh, the foundation, the relation or the formulation that he suggested was the simplest type, and we're not using it right now, but uh, we used it to develop better and more general formulations. I'm gonna show you here. You can see Terzabi suggested different formulations for different uh, foundations. For example, for square foundation and for circular foundation. Here you can see that generally we have three terms. This one, this one, this one, and this one. Here you can see that we have C in here, we have Q in here, and we have gamma in here. If you want to consider the effect of the soil below the foundation, as I said, for example, the effect of the water. When you have water, for example, the dry, we have different gamma. I think you know it from soil mechanics. Gamma D, gamma prime, gamma saturate. Okay, this is submerged. This is uh, when we have soil, a dry soil. Okay, no water. We use gamma D. When you have water and soil, we have two different gamma. One of them is submerged. It means gamma saturated minus gamma water. The other one is saturated gamma. Do you know what are they?
Yes, teacher.
Okay, so uh, this term mainly defines the situation of the soil below the foundation. So we call this gamma term, we call this Q term, and we call this C term. This term for cohesion of the soil, this term for the weight up, above, and this term is the situation of the soil below. In even in developed and new formulations, we have these three terms because the soil is soil, but they are not these formulations. First of all, they are just for They are limited and restricted for a specific type of foundation. You can see it here. This foundation, for example, is just for square, and this one is just for circular. Also, these uh, factors here, for example, 1.3, 1.4, they are not precise. So, uh, um, so um, we needed to develop a new and a general foundation. But what about N gamma, NQ, and NC? From now on, you'll need to use them for the rest of this course. So whenever I ask you to find a capacity, or uh, if you need to check, for example, anything, from now on, you have to find them and you have to use them. What are they? If you remember, or you can see it here, as I said, we for finding, uh, let me erase this one. For finding the final capacity, for finding the final capacity, you have to form or you have to know this shape. Okay, what is the main parameter for forming this shape? You can see that phi is the most important parameter here. So if you know phi, you can form this shape. But you can see that it's not easy to form this shape. That and when you form this one, and you have to again you have to calculate some other things to find the final capacity. So researchers uh, perform this shape, form this shape by knowing this field or simplified this procedure by suggesting these three parameters: NC, NQ, and N gamma. Okay, NC, NQ, and N gamma. So you can see it in all these in all these factors. If you know phi, you can find NC, NQ, and N gamma. As I said, people and researchers developed or developed more accurate equations for finding the capacity of the soil. And the difference between all these methods is finding accurate NC, NQ, and N gamma to form uh, accurate shapes. Okay, accurate failure surfaces. For example, here you can see that there's uh, yes, here you can see that there's uh, suggested these three equations for NC, NQ, and gamma. Okay? For finding them, you need to know Kc, Kq, K gamma. Okay, let me see if I can find the equation for K. I don't know if you learned the passive and active uh, force in soil. The K is same. Anyway, uh, Anyway, this is the equation for NC, NQ, and gamma. I can't find the K here. But you'll see that it's not easy to calculate each of them each time. Okay, so for example, you want to find, you'll see that there are lots of calculations here. To make this easier, any uh, researcher suggested uh, his own table. Let me see if I can find the other table. Yes. So what are these tables? If you know your phi, okay, you can use this table. For example, you know the phi is 10, okay, 10 degrees. So instead of uh, calculating these formulations, you can use this table and see that, for example, if you put 10 in this equation and the equation of Kc, you'll see that Nc is 9.61, Nq 2.69, and N gamma 0.56. Okay, so instead of doing these uh, calculations, you can easily use these tables. And if you know NC, NQ, and N gamma, here you can see that. Where here, if you know NC, NQ, and N gamma, okay, you can easily find the capacity of your foundation. What was B? If you remember, B was the width of the foundation. So here is this is B, this is DF. So in this here you can see that N gamma from table, NC and NQ from table. What was Q? I talked about Q. Q was gamma DF. Gamma is given, and what is C prime? I told you that C prime and phi will be given, so you're not no need for finding them. So C prime and phi prime from test, so you'll have them, and Q from this equation, B is the dimension, and DF also is the dimension. So what you can easily find the total capacity using this equation for a square foundation. So if I ask you, for example, let me see if I can show you an example here, for example. This is one of the examples that you can find or you can solve using this equation. It says a square foundation is 2 meter in 2 meter in plan. The soil supporting the foundation has a friction angle of 25 degrees and C cohesion 20 kilonewton per meter squared. Uh, the unit weight of the soil Q is 16.5 kilonewton per cubic meter. Determine the allowable gross load on the foundation with a factor of safety of 3. Assume that the depth of the foundation is 1.5 and the general shear failure occurs in the soil. What is the general shear failure? That means uh, the, the dominant or uh, the final failure is this. Okay, so for example, in some cases you may have, for example, I don't know, a river here. For example, you have a river here, and because of this river, we may have different type of failures. For example, collapse or runoff or whatever. It says that here we have the dominant failure or the most probable failure is shear failure. This is the shear failure. Okay. If you remember, for example, when we have uh, uh, I don't know if you remember it, for example, when we have a cubic element here, when we have shear force, we'll have slippage or slide against each other. It's exactly like this. Okay, let's solve that example. I'm gonna show you in 3D. It says this is our foundation. Two meter, 2 meter. A square foundation. And we'll have a column in the middle of this foundation. I don't know what is this. As I said, do not make mistake. This is not df. This is the thickness of the foundation. So, for example, in our case, here, this is 3D view, and now I'm gonna solve it into, this is our foundation. What was df? 1.5 meter. The dimension 2 meter, and the other one is also 2 meter. Q, or they are given C prime 25 kilonewton per meter square. 5, I think C was 20. Phi is 25 degree, gamma 16.5 kilonewton per cubic meter. First of all, you have to check the units to see if they are consistent. For example, one of them is meter, the other one is feet, or one of them is Newton, one of them is pound. So you have to make them consistent. Okay, now let's see the equation. What was that? Square foundation. So if I ask you, for example, find the total capacity based on terms of a equation. So what was the equation for terms of it? For a square foundation, 1.3 C prime and C, Q and Q, 0.4 gamma B and gamma. Okay, so Q U is 1.3 C prime and C plus Q and Q plus zero point 0.4 B gamma and gamma. Okay, C is known. Q is known. What is Q now? Q is 1.5 dot. This is the, or let me write it this gamma df 16.5 dot 1.5. Okay, let's find NC, NQ, and N gamma. You have two options. One, follow this one. It's obvious that following this one is more difficult than using this table, because if you want to follow this, you have to first find this one. Here you can see it. It says it is extremely tedious to evaluate Kc, Kq, and K gamma. For this reason, Terzaghi used an approximate method to determine the ultimate bearing capacity. Here,
Teacher,
what?
uh, if you want to calculate with the calculation, how we can find the K? There have the
Here you can see it here. In the passive and active soil, passive and active chapter of soil, you'll see the equation of K. Okay, there are factors that You have to find them based on the geometry of the failure. Here, for example, you can see that it's from soil mechanics. I don't have its formula right now, but if you want, I can give you in the next class. But it's from the soil mechanics. They are the factor of the soil. Anyway, let's find NC, NQ, and gamma. Here, you can see that this is our phi. So NC is 25.13. NC 25.13. NQ
12.2.
12.72 and 8.72.
8.34.
8.34. Okay, so everything is everything is known now. If you yes, NC and Q, we have Q, B. What is B? 2 meter, and gamma is 1. So here you can see Q is this one. Depends on our case. Phi is 25. NC is 25.13 and Q is 12.72 and gamma is 800. Q is what was the why okay, here you can see that Q is 1.5, that's 16.5. This is Q. Gamma is here, B is here, everything is here. So the final answer is this. Okay. But here you have to pay attention to the final purpose of the question. We have two answers. One of them is Q, or lowercase q. Here you can see that. It gives ultimate capacity. Okay. Before, you all know the difference between P, for example, load, and sigma, stress. What's the difference? P divided by area is stress. Do you remember? Do you remember this? Force
Yes, yes.
divided by area is stress. So in this equation, Q is stress. We called it capacity. So you have to pay attention to the final purpose of the question. Here you can see it says find the allowable gross load. Okay, allowable gross load, not allowable capacity or allowable stress. Again, you have to also pay attention to this one. This means ultimate. Okay, ultimate. But this one is allowable. If you remember from strength of material, allowable stress or allowable capacity is ultimate capacity divided by safety factor. Okay, so pay attention to the notations. So allowable is this, and as I said, both of them, Q or lowercase q, are stress or capacity, and Their unit is kilonewton per meter square, or pound per feet square, or whatever. They are not, for example, kilonewton. They are not pound. Okay? So if I ask you to find the ultimate or allowable load, what should you do? You should, this is Q, or capital Q is force. Q ultimate is equal to this Q dot area. As I said, this is stress and this is load. Or allowable Q is Q allowable dot area. Let's continue our example. You saw that. You can see it here. The final capacity or ultimate Q is 1000 or 1078.29. Okay, this is, you can see it from the unit. This is stress. So how can we find force? As I said, it says allowable, not ultimate. To find the allowable, you have to find this ratio. Ultimate divided by factor of safety. So the allowable Q is 359.5. But the capital Q or load is area, that's this one. What was area? It was a square. So 2.2 is the total area. Understood?
Teacher, for the finding area, we have to take only B. We don't look on the DF, yeah?
Yes, it's planar area. Let me show you here. Here you can see this is the area. Two dot two. This is a square. As I said, D is something else. You just need D to check and to find the weight of the soil above the foundation. Okay, so let me explain it again. The answer of this one was 1078 kilonewton per meter square. First of all, this is ultimate. But in the question, it is asked to find all allowable, not ultimate. So, as I said, allowable is ultimate divided by factor of safety. Again, in the question, you can see that the factor of safety is 3. So, Q allowable is equal to 1078 divided by 3. It's about 359. Okay, again, it is stress, kilonewton per meter square. Again, you can check this, check the question and see it is asked to find the load, not stress, not capacity. So if I want to find load Q, I have to multiply stress in area. So 3.59 that area, because it's square, area is B squared. And the final answer is 1438. So the final load is 1438. Look at the unit, kilonewton. This is force or load. What does it mean? What does it mean? That means, for example, you have You have a structural analysis in this course, yes, or architectural analysis. What do you have in this?
No, architectural structures. We have this.
Architectural structures. Okay. In this course, you'll find, for example, if you have, for example, you have this structure with this loading. For example, these are dead load or whatever. You'll learn how to find the force, for example, in this column. Okay. For example, you have a load of whatever. For example, you have a load of 500 kilogram per meter square. This is your structure. After the analysis, you'll see that the force in this column is, for example, 1,200 kilonewton. If I ask you to, for example, or if I ask you to check if a foundation with a dimension of 2.2 and with a soil of C prime 20, P 25, gamma 16.5. If I ask you to check if this package of the soil and foundation is reliable or not, you should follow this process. What was the result of this process? The force of this. So the capacity of the soil, the capacity of the foundation is this one, and the load or the applied load is, for example, this. So you can see that capacity is more than applied load. So you can say that this is good. And you have to notice that you used a factor of safety of 3. Okay. Do you have any question?
Teacher, if it is more than capacity, it's failure.
Yes. You have to. You as an engineer, you should reject this project.
If it's equal to the capacity, what will happen?
If it's okay because you used factor of safety of 3. If you use factor of safety of 1, it's not reliable because everything is it's close to the failure. But when you use factor of safety, you can say capacity should be greater or equal, okay, than applied load.
Okay, teacher.
Okay, it's enough for today because your friends are not here. Any other question? Or I'm gonna finish this class.
Okay, teacher. Everything is clear. Thanks.
Okay, okay. See you next.
See you, teacher.
See you, sir.
See you, teacher.